We're going to get to work on another game now. This one's going to be called The Floor is Lava. How exciting. As you might guess, the aim of this game is to juggle as many balls as you can without any of them actually touching the ground. Now, unfortunately, I do not have any trailer footage to show you, because at the time of recording, I have yet to actually make the game. However, we are going to start with the player character, just like we did last time. However, instead of making the character as a type of rigid body 2D, we can just use a different type of physics node called a kinematic body 2D. And this is because in this game we don't really need the player to bounce or spin or react in a physicsy way when it collides with another object, but we do still want it to move around, so it can't be a static body 2D either, which is designed for static collisions. Things like walls, floor, maybe a moving platform, I guess, but still. So we can actually just get right into creating the player character. So the first thing that you might notice is that I've actually already done stuff in this project. I have created this 2D tree root node, and I've called it main, and I've saved it under scenes. And the reason that I've done that is because I actually want this project to be a little bit more organized. So I'm going to be using folders for things. Very simple structure. It's only going to be going like one level deep, really. But anyway, yes. So we can create a kinematic body 2D to be our player character, and I'm going to name that player. Again, basically just what we did last time, except instead of using a rigid body, I'm using a kinematic body. And I think you'll find that most of the setup is actually very similar. So I'm just going to create these two things. I'm going to load in a sprite first of all. There we go. And this player object is actually going to be a paddle, because this game is all about, bouncing balls up there. So I'm going to elongate this sprite, making sure I have the appropriate snap settings enabled. Just going to keep it centered. And this is going to form our paddle. So now if I just drag this down here, I open it, you should see we have a nice little paddle. And another thing, I'm going to need to create this collision shape, because that's important. But once we've done that, that's basically it. We've set up, well, we haven't set up the entire play, but we've set up all the inspector editor stuff side of the player. So now we have to add a script, otherwise the player will not be able to move. And an interesting difference you might notice, actually, just right off the bat, is that this player object does not immediately start falling, and this is because it's a kinematic body which doesn't have any built-in stuff for gravity. So I'm just going to create this script, going to delete some of these comments, and I am just going to populate this with the code to move our paddle back and forth just along the x-axis. So there we go, I've put my code in, here's some variables up top. I've got this process x movement function, which I'm just putting everything. I don't know if I would do this normally, but it just helps to make things more clear. In physics process, we're processing the x component of the movement. I'll show you what this looks like before I explain what it's doing. So there we go, nice simple movement. It's pretty fast. I feel like I probably want the movement to be quite fast in this game, since balls, they can be moving quite quickly. You can adjust the speed if you want. So basically what we're doing is we're saying we have this velocity vector 2. And what we're doing is we're just changing the x component of this vector. And we're saying if the left arrow key is pressed, then just subtract speed times delta. Then we're also always degrading the velocity, always multiplying it or reducing it by 10%, so that we get this kind of slowdown effect, like a slide, if you see, like that. And also we're just capping the velocity between -20 and 20, and this is exactly the same line of code, or it's very similar to the one we did with the rigid body in the last section. The only difference is that instead of linear velocity, which is a member variable of rigid body 2D, we're just using our own variable which we defined ourselves, and then we're running this last function, which is move and collide. Now interestingly about move and collide, it will automatically just not move the object if it runs into a wall. I don't have any set up at the moment, so I won't be able to show this off yet. But if it does run into a wall, it'll actually return a kinematic collision, which is an object which contains information about what happened during that collision. So it gives you the colliding body, it gives you the angle of collision, it gives you all these really nice things you can use to implement other stuff like bounces or pickups, anything really like that. So cool, we've done the X movement. So one more thing I might want to do is actually give the player a little wobble, because if you notice, I'm not sure how nice it looks just having them, slide back and forth like this, like it's on a rail. I want it to feel like the player is actually pulling this paddle back and forth. So I'm going to just do a little bit of tilt on the sprite, and I'll show you how we can implement a function which will only interact with the sprite and not the whole body. Okay, so this is our code, and what this is actually doing, you might notice one thing, I've added this variable angular momentum, and when the player moves left or right, I'm just adjusting this variable. It should be either positive or negative depending on which way I want the player to tilt. And then I'm also doing some calculations down here to adjust the angular momentum based on the sprite's rotation. So what this does, it creates a kind of further away from 0, the further away from not rotated at all that it is, it's going to be adding more to adjust the momentum. It's going to be pulling back a little bit harder like a spring. And then I'm also just setting the rotation here, and I'm reducing the momentum by a random float value here. And I've also got these, again, these constants at the top, which you can play around with, and you will get some really intense results. If I put some of this stuff up too much, it gets pretty crazy. It just spins all over the place. So this is what the effect we kind of have. As you can see, it is just like a spring because we're doing that, or accounting for the sprite's rotation in the momentum calculation. And one other interesting thing, and the reason why I didn't do this, you see down here I'm using this notation which is $sprite dot rotation. This is accessing the sprite node and it's adjusting the sprite's rotation. You might notice if I click on the sprite in the inspector, under transform I have this rotation degrees thing, and I can set this to 130, why not? If I go back up to my main object, the rotation is still 0, and I could set this to minus 130 to even out the sprite again. But I'm not going to. I'm going to leave these both at 0 actually, because I want it to be adjusted by the script. So this is the notation for doing this. Another thing that we could have done is get node. We could do get node sprite. That would also work. However, it's a little bit longer. I would use this for longer file paths. If there was something which is a little bit obscure, then I would surround it in those string literal quotations. For the purposes of this, I'm just going to leave it like that. So I can actually show you what's going on here. If I reveal this collision shape, we can go up to debug and press visible collision shapes. Now what happens, you might notice, the collision shape is staying steady when I'm adjusting the rotation of the sprite. And the player would never usually get to see this, and yeah, I guess it's not congruent in terms of hitboxes if you wanted that really precise hit collision. But we don't in this game. It's pretty simple. We just need the player to know when they're about to hit the ball and then see the ball getting hit. Now the advantage of having this thing flat is that if the ball is coming down and we're tilted, we could end up hitting the ball in the other direction. If it's just flat, then the X velocity is going to be more or less unchanged, and we're only going to be dealing with the Y. So this is pretty cool, and this is going to be the basis of our player character. That's it, actually. Thanks for watching.